So thank you very much for coming. This is the first time I'm showing this. And also probably the last, because it's a prototype that I worked on, and I'm going to throw it away after this presentation. And keep working on it, but this exact piece of code is not going to live on much longer. So what I'm working on is this project where I'm working mostly on developing user interfaces on the web, running in the browser. So take, for instance, something like a mapping toolkit, so something like Google Maps, Apple Maps, Mapbox, OpenStreetMaps, whatever. And you have a lot of very complex interactions. You want to download a lot of data, map data that you want to display. So you have all these tiles that you need to stitch together to show the map. You want the user to be able to pan and to zoom. So when you pan and zoom, you need new tiles to display. You want to animate the transitions if you want to show search results. And search results, of course, you need to make web requests to a server to send you new results to show, and then you want to show annotations on your map for the search results with animations, and you need to synchronize everything. And you can do that with a lot of async await, of promises, of callbacks, but it becomes a huge mess. It's really difficult to test and to debug, because every time you have something asynchronous, you cannot really break anywhere. If you want to test, you must make sure that you test for the whole duration of a process before you can ensure that you have everything under control. So I've been thinking a lot about what we could do to make that sort of development process better. And I turned to, in the spirit of the future of coding, to the past, looking at things like synchronous languages, which were developed a lot starting from the 80s. So things like STRL, for instance, which is used for automation, things like trains and planes and nuclear power plants and things like that. Also Smile, which was a W3C specification from the late 90s to early 2000s, which was specifically designed to synchronize multimedia content. And basically the ideas from this are that you either want to do two things. So this is the top of my presentation. You want to do either two things in parallel, or you want to do two things in sequence. And then you want some combination of that. So sometimes you want all these tiles in the map to load together, but you want the tiles to load before you want to show the annotations, for instance, because you don't want to show annotations on an empty map. So you do, in parallel, you do all the loading, and then in sequence, you do your annotations. So you want to make sure that everything has ended, and then you can do the next thing. So that's parallel. Sequence is doing one thing after the other. Repeat is a kind of a sequence where you repeat the same thing over and over again. So you do something, and then when it's done, you do it again, and when it's done, you do it again. So what do you want to do? You want to do some things. Either you want to do something instantly. So we want to mix the synchronous aspect of programming, where things happen instantly. So you do something, and you have a result straight away. No time passes. So you add one to an element, you toggle a class list on an element. So that's called an effect because it has side effects, but that's because JavaScript doesn't make a difference between the two. I'll tell you later why this is important. Or you want to wait for some amount of time. So those are the primitives. So you wait for 1 minute, 30 seconds. You don't do anything, okay? And then you can do something else after that time has passed. Something more, so it's useful in some cases. Sometimes you want to wait not for some time to pass, but for something to happen. So for instance, if you have an input element on your page, you want to wait for a change to happen. So the user types some text, so you're waiting for text to arrive. And when you have some text, then you can do something else. So if you want to do search, you wait for the user to type some input, and then you can search based on that input. Or you can start a process that's asynchronous, and then it will end after some time. So if you want to fetch data from some URL, it's going to take an unknown amount of time. So you want to wait for it and then do something with that data when it's available. And because, so these are the primitives of both a visual language, which you see here, but also this is implemented in JavaScript, and you can just use it in text form. So because it's designed for the web, you also want to manipulate elements. You want to set some properties of these elements. So the text content of a paragraph, the URL of an image. And so those are the primitives. And then we have two important concepts, which are these two modifiers, which let you do something for some amount of time. And time can be, time. So you want to do something, and it must last 23 seconds. Okay, that's a set amount of time that you give it to last. Or it must last 3 iterations. So you want to repeat, but only 3 times. So repeat is forever. But you can say, okay, I'm only interested in the first 3 iterations of my repeat. So with that, you can manipulate time in your program. Of course, you can also say that you want something to last forever. So you have an image and you want to show it, and you want it to show forever. So here's a simple example. So if you know visual programming languages like Max MSP or Pure Data, for instance, this is quite similar. So here I have an example, a test patch, where once this program starts, there is a button here, and I have 1.35 seconds to click it. And if I click it within 1.45 seconds, I have to click it 3 times, sorry. So I have this button, I'm waiting for a click event, and I'm waiting for a list of click events, as many click events as possible, but I'm only interested in the first 3. So after 3 click events have happened, then I do the next thing, which is just generating an OK value. At the same time, so this is first is exactly like par, like a parallel element, but sometimes you want to make sure that you just want the first thing to happen. You want several things to happen at once, and then you just want the first one to be the value that you want. So at the same time, I start a delay for 1.35 seconds, and same thing, once the delay ends, I generate this value KO. So either I have 3 clicks of a button, or I have a delay that expires, so it's a timeout. So either I have OK or KO, and whatever the first one happens, this sequence finishes. And then when this sequence finishes, I set the text content of this text element. So I have these dotted lines. So here it means it's a reference to an element. So I will set the text content of this text element, so it's a text node in HTML, for 2.5 seconds to the value that I've received in my sequence. And score is just the top level of my here. So let's see it in action. So I press play. So I have this quick button. Okay, I wasn't very quick enough because I was explaining. So it said KO because I didn't click it. So let's try again. I will move closer. Okay, 1, 2, 3. Ah, still not fast enough. Okay, one more time. 1, 2. Okay, okay, I made it this time. So here I have this play pause button. So the point is that because I have an explicit representation of time, I want to be able also to manipulate the time. So this is the part that doesn't work. So I cannot show it to you. You have to imagine. But the point of this whole endeavor is not just to create this sort of a visual language for writing a visual interface, but also to be able to debug and to test it. And in order to debug and to test it, I want to be able to play things backward, to play things faster. So if I have an interaction that is supposed to take 3 minutes, I don't want to take 3 minutes to test it. I want to run it as fast as I can and verify that after 3 minutes. So that's why I'm working on this transport bar concept where you can play, pause, stop, etc. As you can see, there's no back button yet, but that's going to be the next when I work on the next prototype. Another thing which you can see at the bottom, it's not very clear yet, but because this is also the timing is explicit, I want to be able to represent it graphically. So I want to show a timeline of what is going to happen. And because when you see this program, at first glance it might be a little difficult to parse. Even if you're used to it, you need to think about it for a while to understand what's going on. But if you have a timeline that shows things in with the timing that has been resolved after the user has pressed a button or not, etc., then you can find out more about what's going to happen. So if I play again, if I stop and play again, we can see this little green dot, and this little green dot was basically this delay finishing, and this other green dot was this other duration finishing as well. So I know when I play again, I know that there are things that are going to happen, right? So if I pause here, I know that I'm not in the final state of my program, right? I know there is more stuff to come because there is some event. So this is a very, very preliminary implementation. Of course, the point is to make things much more descriptive so that it will not just tell you that there is something happening, it will tell you that this set is ending, so this text will disappear. Okay, so maybe I don't have too much time left, so I will show a couple examples. So this is implemented in JavaScript, and you don't have to use the graphical interface. You can also write JavaScript code and insert it in your web page. So here is a small example of an animation. So the first loop is a bit sketchy because it takes time to load the images, but once it repeats, it's fine. So basically, I have a sequence that I repeat forever, where I just generate a range of 18 numbers from 1 to 18. And then I apply in sequence generating the name of an image from that number. So it's tomato 1, 2, 3. And setting the URL of an image element to this src for, so FPS is some number that I've put in my program, which is here it's 9 frames per second. So every 111 milliseconds the image will change. And at the same time, I'm also setting the text content of this element, so I can see what the frame is playing. I can also change the playback speed, so I can play faster, and I can play slower. So if you are developing your animation, it might be interesting to be able to see things slower. Here's another small example. So how to drag an element. So dragging, same thing like it's to do a user interaction. Basically, you want to have some pointer down event on your element, then you have a bunch of pointer moves, and then you have a pointer up that signals that the drag has ended. So you do a sequence of a pointer down, and then you do a sequence of, so first you need to recall what's the original start point, and then you repeat, for every pointer move, you call this function, which basically just translates your element from the original position. But sometimes we want to do more than one interaction. So here I also want to be able to just tap on my element. And when I tap, I just change its color. So when I have a pointer down, I have two choices. I can drag or I can tap. But I don't know yet what it's going to be. So again, I'm using this first thing, which is really important. So in parallel, I'm just doing something where I listen to a pointer up event, and I change so tap is just pointer down and then pointer up, right? So after I have a pointer up, then I can change the class of my element. But if I drag instead, actually this drag will end at the same time as this pointer up event will appear. So I have two pointer up events, so they're both the same event. And because this ends, this will end the interaction, so this effect will not happen. Because when I have two things in parallel in the first, and the first one ends, the others are cancelled and they cannot go on. So the point is that I have a very deterministic model of time. Even when things happen in the same instant, there is still an order because these things are in sequence. So if you have a sequence of A, then B must happen after A. And if something happens between A and B, then B will not happen in this case. So I think that's basically just another example. So the point of this is that you want to be able to include that into a larger program. So here, the code is not really important, but what's important is that, for instance, there is more code for drawing than for the actual synchronization of elements. So the synchronization is just that I repeat for, I have 15 circles, and for each circles I just generate a little bit of code to synchronize the animation. Everything has a different duration, so that's why we have this effect. But then it interfaces with the JavaScript code, so I'm not well, that's the interface between your code. So the point is that in the future it should be able to work whatever other framework you're using or not. So it should just be there to help you and get out of the way when it doesn't. So I think that's it for me. If you have any, I hope that was okay. So I have about 2 more hours of talking about it if you want. So if you have questions, then I'll be happy to. Yes?
Yeah, this kind of representation of like time and space is very cool. Wouldn't it be even cooler if it would be a standalone language in its own?
So that's the future. So when I said I was throwing this away, that's because I want to focus on developing the actual model. So really the core of the system. So it's language independent, because really I just want to work on these synchronization primitives and all of the things you can, all the patterns you can create with them. And what you synchronize is secondary at the moment. And I want to be able to do what I wasn't able to show yet, which is go backward or show the whole timeline. So this is what I'm focusing on. But in the future, I also want to build up this to be a full-fledged language. So right now, in this example, this is hosted in a web browser in JavaScript. So if I have this instant and these effect things, they're basically hosting some bits of JavaScript code. I don't know what's happening in them. And that's why effect is important, because if I want to go backward, then effect has an effect. So I need to be able to undo the effect in some way. But if I have a full language on top of it, then I won't write in JavaScript here. I will write in the language. So that's exactly the sort of directions I want to go. But that's several years away, I think. But I still want to develop also this visual language, and my sort of long-term goal would be to have something along the line of HyperCard, where you can build your whole interface visually, but instead of dropping down to HyperScript for the code bits, then everything would be in the same interface. So that's the dream for the moment. Okay, thank you. Oh, and it's on GitHub if you want to look at the code. And so everything I've shown is in the proto directory, so it's hidden because now it's the real code is not doing a lot yet because I threw everything up.
Thank you.
Thank you.